Now let's start with the next part called as set reset. It's also called as a latching here. Now what do you mean by a latch circuit? Now latch circuit is nothing but it's a circuit which has two inputs and one output. Now it's a very commonly used circuit and you will see that in many cases you will have to use this. So we will try to understand this kind of a circuit by taking one example. Now before that, let's try to understand what do you mean by exactly the set and reset here. Okay, so just let's take any kind of an example of you're having one open switch and you're having an lamp here. Now what does this set reset does is that, let's say you can look it here, look at the ID here, it is 0500, it is an output here. Same here we're having here same ID 0500 with the reset. RES stands for reset, SET stands for the set value. So if you look at the address value, both of them are same, means that both of the output is same. But look at the input here, both of the input address are different. It means that they are different inputs here. So one input is used to switch on this output, that is called as an set here. And similarly, if you use another input here to reset it, means to bring it to the initial position, to the off condition, that thing is called as an reset. So it is called as RES. So in this case here, to have the simple operation of off and on, we will have to use this two input, or simply we can say that set and reset, we will have to use two inputs here. So this example is actually quite useful in our cases. So to understand in detail here, we will take one more example. Now you might have noticed this image here. Now such kind of a thing is very common when you are trying to switch on a motor here. It in the different practicals in your labs you might have come across where you will have to use such kind of an switch here. So this thing is called as a push button switch. Look at the symbols here, you might recognize that if I press on the X1, that is the green symbol, then my motor will start on. And if I press on the X2 here, then my motor will switch off. Right? So here if we can see here, if we take example of motor here, then you can see our motor is an output and our input is this two push buttons here. Right? So now what is the peculiarity of push button? If you click on the X1 here, what will happen is that it will get pressed and then motor will start, and as soon as it will return back to its original position. Now even if the button is into its original position, our motor is still running. Right? To switch off the motor, we will have to press this button X2. So same thing we can represent it by using this ladder logic diagram. So let's see what has been mentioned here. Now if we look at this diagram here, now I have kept purposely such kind of an information here. In the last example, you might have come across that here we have used these addresses. Now here we have used this kind of a text here. Now what difference is that? Actually both of them are right. We can show here this information by either using the address field also, by using the text also. This is called as the naming. Here we have given the name to this kind of a circuit. Right? So we can do both the provision. Even there is one more thing called as input and output that we will see in the one more numerical later. So we'll just try to understand here how the circuit is being shown here. Right? So we have two inputs. So input A and input B is shown. But here difference is that look at the input A. Now input A here is an open circuit and input B here is an closed circuit. So what does this means here? Open circuit means that in the normal condition it is open. There is no provision through which the supply can be transferred. But if we compare for this input B switch here, now it is normally closed. It means for in the normal connection, even when there is no supply there, what will happen is that it will allow the connection to pass through it. So what happen is that if I press X1, so this switch will get closed and the connection from the left to right, it will pass in this direction. It will pass directly through it. And then it will try to energize this relay coil C. Now as soon as the C coil is energized, so what we can do is that we can internally, this connection is there in between this part here. Look at the C symbol, both of them are same. So when this thing becomes energized, what will happen is that it will try to energize this part also. So that's why what happens is that the push button rule helps here. So if we look at here, what happens is that, now let's come back to the again initial part. Now when X1 is pressed, what happens? It just try to push forward and it connects it. So what happens is that this thing gets closed. Now immediately the supply goes in here, it energizes this call, and in return it energizes to this kind of a switch here, and this gets closed here. Now when this button, after pressing it goes back into its initial position, so this switch will remain open. But now, as in the case, this coil has become energized, which has indeed energized, or it had made this coil as a closed one. So what will happen is that now the supply will flow in this direction even though input A is open. So this supply will be maintained continuously. And how does it help us that? If we look at this connection here, again the C connection is here. So when this thing becomes energized, obviously this thing will also get, and this will become an closed circuit. Initially it was open, but when this becomes energized, it becomes closed. So now supply is being passed through here into this output D here. So here we can see that even it has returned back to its position, still our motor is running, right? So this thing is called as an continuously running, even you have pressed this button, but it has returned back to its original position. Now to switch off the motor, what you will have to do is that obviously you will have to push this X2 button here, the red switch here. So what happens is that as soon as if I press this switch here, look at the input P symbol here, it is normally closed. So as soon as we press that, it will become an normally open. So this supply won't pass through this C here into this part. As there is no supply here, there will be no connection to this relay coil C. So it gets de-energized, and in return it will de-energize this C also and this also. So when this thing becomes de-energized, this becomes an open switch here. So there will be no supply here, and in turn there will be no supply to this motor T here, right? So in this way, this process is called as a set, reset or latching process, where you will have to use one input to switch on the motor, and you will have to use the second input to switch off it, right? So such example we use many times in our lengthy numerical. So now let's move towards the next part. Now what we are having here is that we will try to discuss the topic of timers. Now as the heading says here, what it does is that timer is something which like listen to the instruction which you tell it. So what it will do is that, let's say if you tell it about that after 3 seconds your motor should turn off, so it will behave accordingly. So if we talk about the timer here, timer comes under 3 types here. The first one is the on delay. What do you mean by on delay? Now if you take example of, let's say, open switch and an lamp here, they are both connected in series. Now normally what happens when you push the switch, it becomes a closed switch and lamp gets turned on, right? Now if I place timer in between them, open switch, timer, and the output, that is the lamp here. So what happens in case of on delay, when you press the input, right, then the output gets on by after certain time. Let's say if I set the timer as 3 seconds, so what will happen is that even if I press the input, my timer will record it, and then after 3 seconds it will pass on the supply and the output will get on here, right? So in on delay, after 3 seconds, after certain time, our outputs get turned on, while in the off delay exactly opposite occurs. Here what happens, when input is given on, then your output is turned immediately, But then what happens? Whatever time you have decided, only the output will stay on for that particular time. Then after that, it will get off. If you look at the third type is called as an retentive or accumulating timer. Now in this type of timer, what we have is that we are having two inputs. One input starts the timing and the another one, it resets the timing. Right? So if you look at the example here we are having like a description about the timer. Now this case here of the enable part, right, it is a typical example of this on and off delay timer. If you want to look into this third type, it is of this part here, right? So if you look at here, one input enables the part, it starts the timing, and second one, it resets the timing. The timer is being shown by this symbol. Look at here, where T000, like here we have shown TXXX. This XXX indicates the address number. Type the sequence of a timer here, because if in a given simple question you might be using 4 timers, 5 timers, so all of them should need different address, right? So it is mentioned by this TXXX, where YYY indicates the number of turns here, the times here. So here it is given as 100. Now what does this means here, 100, that we will discuss here. So if we take this example here, like this T000 timer, let's say it ticks 100 times. Here 100 means that it ticks 100 times. So let's say every timer has certain kind of an configuration, that it's have an increment timer here. Now that here in this case, for example, if we take that, let's say this T000 timer have an increment timer of 50 microseconds, right? So what from this 50 microsecond, we can calculate that what is the total time here. So how can we calculate that? We know that this timer will tick 100 times and the increment time here is of 50 microseconds. So what we will do is that we will multiply 100 by 50, 5000 microseconds. So which we get that 5 seconds. So this kind of a timer here is of an 5 seconds. So it will show an property behavior after an 5 seconds. It depends upon whether it is on delay or off delay. Right? So this kind of an information, specifically this part, is very important to understand when we are trying to solve an numerical here.